video is on writing chemical equations if we're given a sentence or a word equation. Now, we'll do a little review of naming and then get into some examples. So, keep in mind that reactants are always on the left side, and they yield products. So this arrow we called yield. You can have one reactant, and you can have many products. You can have many reactants to go to just a few products. It doesn't matter the numbers that you have. If you are given a sentence or a word equation, and you see the following things. So, for example, if you see something combined with something else, if you see one substance reacts with a different substance, if you just see first substance and second substance, all of these mean that we're going to add our reactions together. If you see anything, something like this, decomposes, forms, yields, produces, there's several out there, but these are the ones you see most often. If you see anything like that in the sentence, that means we're going to draw our arrow. And we're going to have to figure out what's happening in the equation to write our chemical equation. Now, in word equations, it also wants you to include states of matter. So just a quick summary, if you see if your substance is a solid, then you will have to put a parenthesis S, end parenthesis, after your formula. And that's a solid. Solids are also called precipitates. So if you see solids or precipitates, that we are going to abbreviate it like this. If we have liquids, we're going to do the same thing. We're going to put an L in parentheses right after our formula. And if we have gases, we're going to put a G inside parentheses after our formula. There's another thing. We call it aqueous. Aqueous, well, aqua means water. So aqueous are things that have been dissolved in water. Such examples are solutions. Like if you have a saltwater solution, it's sodium chloride, NaCl, table salt, dissolved in water. Other things that are aqueous are acids. So if you see, for example, hydrochloric acid, then it's going to be aqueous. And so the state of matter that we put is a AQ in parentheses. This little symbol right here, that's my Q, my lowercase cursive Q. We also have to keep in mind our diatomics. There are 7 elements that are diatomic. Now, what does diatomic mean? Di means 2. Atomic means atoms. So when we are talking about our diatomics, then we're going to have 2 atoms that are bonded together. They don't just occur as one individual atom, they come as a pair. Always in their natural state, come as a pair. So bromine would be written as Br2, iodine would be I2, nitrogen would be N2, chlorine is Cl2, hydrogen by itself is H2, oxygen, and fluorine. One way to remember these diatomics would be to spell out Brinkelhoff. So if we put the first letters of all of these together, we get something like this. Brinkelhoff. Not the best grammar or spelling of this word because I have trouble spelling it. But it's one way that we can remember all 7 of our diatomics. You will see these diatomics written as Br2 and I2 if they are by themselves in their natural state. So for example, something reacting with bromine, we'd write Br2. Now, if it's in a compound, for example, sodium bromide, we do not put a 2 necessarily unless we are crisscrossing our charges. It's only when it's by itself as its own element do we write it as Br2, I2, N2, Cl2, etc., etc., etc. Now, let's get into some naming things. For example, sodium bromide, if I say that, do you know what the symbol is in the formula? If you need more detailed review on naming, look up my video, CRHS McIrvin naming. I've got 4 out there, one of a different type. First, in summary, ionic is something with a metal and a nonmetal, and your metals are located on the left side of your staircase. Your nonmetals located on the right side of your staircase. If you have an ionic substance, this is when we're going to look up the substance. We look up its charge on our periodic table, and then we can crisscross those charges in order to make the overall formula have a charge of 0. One such example would be something like sodium oxide. We can look up what sodium is, Na, and if we look on our periodic table and we find sodium, it has a +1 charge. Oxide is oxygen. We can look up oxygen. It's just an O. We look on its periodic table. It has a 2- charge. In order to make these equal, I crisscross my charges. Again, check out my naming videos if you have no idea what's happening right now. I do explain it more in depth in earlier videos. So my formula would be Na2O. Another quick example would be if we have something like iron. Let's do iron 2 sulfate. Iron 2 sulfate. All right. Anytime you have a metal that has a variable charge, we have Roman numerals that tell us the charge. Makes it really easy for us. Iron is Fe with this Roman numeral 2 says it's a 2+ charge. Sulfate, ATE ending, that's not the same thing as sulfide. On the periodic table, that's an IDE ending. So if we're looking up sulfate, then we have to check out our polyatomics, which is up in this left corner. I have a larger view of them here. So if I'm looking for sulfate, up here it says SO4 with a -2 charge. So this is SO4 to a -2 charge. Now, because this is +2, this is -2, they are already canceling to be 0. I don't have to crisscross my charges. I can just simplify this to be FeSO4. That's a quick review of what's going to happen in the next couple examples. Again, if you need some more practice, look up my CRHS McIrvin naming video. If you have a molecular substance, it's a nonmetal and a nonmetal bonded together. Because they don't have charges, they're sharing electrons instead of transferring electrons, we're going to use the prefixes to indicate the amount of our element that we have. Here's our list of prefixes. 1 is mono, di is 2, tri is 3, etc., etc., etc. If you have something that has a double vowel, for example, pentaoxide, as a grammar thing, we're going to drop the A so that it's easier to see. So you may see something that just says pentoxide instead of pentaoxide. It would just mean 5 oxygens. We've just dropped the A to make it easier to say. Alrighty, that's our general introduction into writing equations. So now let's see some actual examples. When you have these word equation sentences, it wants you to write the equation, include our states of matter, and balance. So we're looking for those 3 things for each of these. Number 1, sodium metal reacts with chlorine gas to yield sodium chloride. All right, let's start from the top. Sodium metal. All right, sodium metal, well, sodium is Na. Metal means that it's probably going to be a solid. There's only one liquid metal, and it's mercury. This is sodium. So let's make it a solid. It says reacts with. All right, we've got a reacts with. So I'm going to put my plus sign because we have something reacting with something else. We saw that on our first slide of notes. It's reacting with chlorine gas. All right, chlorine gas. Well, chlorine is Cl, right? But chlorine is one of our 7 diatomic elements, which means that it's not just Cl, but it's Cl2. And because this is a gas, then I'm going to put my parentheses G after my formula to indicate that this is a gas. To yield, all right, so that means that we're going to draw our arrow. And then it says sodium chloride, all right? Anytime you have a name, it's a metal and a nonmetal, we have to look up their charges. So sodium is an Na. Its charge is +1. I'm getting that off the periodic table. Chloride is Cl. Its charge is -1. Because this is +1, this is -1, they are already balancing out to be 0. I don't have to crisscross anything. So this would be my formula. Now, sodium chloride, this is table salt, so hopefully we can realize that it's going to be a solid. We've gotten our equation. We've included our states of matter. Now all we have left is to balance. Here's 1 sodium. Here's 1 sodium. Here I have 2 chlorines. Over here I just have 1 chlorine. So I'm going to put a coefficient of 2 in front. That gives me 2 sodiums and 2 chlorines. Well, now my chlorines are balanced, but not my sodiums. In order to get my sodiums balanced, I'm going to put a 2 in front of here. That would be our equation. Look at our next example. Aluminum metal and oxygen combine to form solid aluminum oxide. All right, let's start from the top. Aluminum metal, well, aluminum is Al. And again, it's a metal, so we're going to put it as solid. Then it says, and oxygen combine. All right, so we're combining oxygen to this. Odds are we're going to be adding oxygen. Something special about oxygen is it's one of those diatomic elements that occurs as O2. Now, it didn't give us enough information for our state of matter. Oxygen, naturally, well, we breathe it in, so I'm hoping you're not breathing in solid oxygen. I'm hoping you're not breathing in liquid oxygen. This is a gas. It's forming, so I'm going to draw my arrow, solid aluminum oxide. Again, we have a metal and a nonmetal, so we have to look up our charges. Aluminum is Al. If you look on the periodic table, it has a +3 charge. Oxide is just O. If you look on the periodic table for that, it's a -2 charge. These are not the same number. They're not the same. They're not going to cancel out. We've got more positives than we do negatives. So in order to balance this to be 0, I need to crisscross my charges. So this 2, not the negative, just the 2, comes down by aluminum, and this 3 comes down by oxygen. That means that I have 2 aluminums, each one with a +3 charge. So I have a total positive, well, 2 times 3, again, I've got 2 of them, so aluminum +3 and aluminum +3, 2 aluminums with a +3 charge. Overall, I have a +6 charge. Oxygen with a -2 charge, and if I have 3 of them, then I have 2, 4, 6. I have a -6 charge. Your subscripts and your charges multiply. That's how you can double check that we're balanced out. All right, so this is Al solid plus oxygen gas yields aluminum oxide, and this was a solid. So we've got our equation, we've got our state of matter. All we have to do is balance. I've got 2 oxygens here, 3 oxygens here. I need to make those the same number. So I'm going to put a 2 in front of here. That would give me 2 times 3 oxygens, gives me 6. If I put a 3 in front of here, that's 3 times 2 oxygens, gives me 6. That changed my aluminums. I have 2 times 2 aluminums, which is 4. So over here I need 4 aluminums. If you need help balancing, I do have a video already posted for balancing. Look up CRHS McIrvin. And it's called balancing. Balancing equations. All right. Next example. Steel wool, nearly pure iron, burns in air to form solid iron 3 oxide. All right, nearly pure iron, so we're just going to say that steel wool is iron, which is abbreviated as an Fe. It burns in air. Okay. In order to burn something, we need oxygen to be in air. Air is mainly made of nitrogen and oxygen. Those are the primary components of it. Anytime you see something that says burns in air, it's reacting with, so I'm going to add my plus sign, oxygen, which because it's a diatomic, I put O2. Now, iron, aluminum, sodium, they are not diatomics, which is why I have not been putting 2's in the bottom right corner. It's only for those 7 that we see. Also notice that when chlorine and oxygen were bonded together, these aren't 2's that come after chlorine and that come after oxygen. It's only when it's by itself that we have diatomics. This being by itself. This being by itself. In these compounds, when they're bonded, I have to look at the charges in order to figure out the subscript. All right, so let's go ahead and add our states of matter so far. Steel wool, well, that's a solid. Burns in air. Air is a gas. To form, so let's draw my arrow. Solid iron 3 oxide. Okay, iron, Fe. This Roman numeral 3 is a +3 charge. Oxide is oxygen. Has a -2 charge. Similar to the previous example, we're going to crisscross these charges. We get Fe2O3. And also similar to the previous example, hold on, this is solid because it says right here, solid iron 3 oxide. Also because of the previous example, we're going to kind of balance this the same way. This is 2 oxygens, 3 oxygens. Put a 2 in front of here to give me 6 oxygens. Give a 3 in front of here to give me 6 oxygens. That changes my iron to be 4. So that would be our equation for this sentence. Liquid carbon disulfide reacts with oxygen gas to produce carbon dioxide gas and sulfur dioxide gas. All right, now we're getting into some prefixes. So these are molecular substances, and we can tell because it says disulfide, dioxide, and dioxide. Think back to my prefixes on this previous page. We had di to be 2. So, if it says carbon disulfide, there's no prefix in front of carbon. That means I just have one. It doesn't say monocarbon, it doesn't say dicarbon, it doesn't say pentacarbon. It just says carbon. So I'm going to have one of them. Disulfide is 2, so that means I have 2 sulfurs. So I'm going to write it like this. And that was a liquid. So I'm going to put my state of matter as an L. Reacts with, that's when I'm going to put my plus sign. Oxygen gas, well, oxygen is O, and because it's diatomic, it's O2. And it's a gas. So, O2 gas. To produce, I'm going to draw my arrow. Carbon dioxide gas. So again, carbon doesn't have a prefix. There's just one of them. Dioxide means that we have 2 oxygens. So I'm going to write it as CO2. That was a gas. And also forming is sulfur dioxide. So I have sulfur, just the one. Dioxide is O2. Again, that's a gas. So I've got my equation. I've included my states of matter. Now all we have left is to balance this. 1 carbon, 1 carbon. 2 sulfurs. Over here, there's only 1 sulfur. So I'm going to put it to a coefficient of 2 in front. That would give me 2 sulfurs here and 2 sulfurs here. That now gives me 2 times 2 is 4 oxygens. And another 2 here is 5, 6 oxygens. In order to get this to be 6 oxygens, I'm going to multiply it by 3. 3 times 2 is 6 oxygens. Alrighty, two more examples. Solutions of sodium chloride and silver nitrate will produce aqueous sodium nitrate and a silver chloride precipitate. Alright, getting a little bit more interesting. Sodium chloride, well, we've already seen that before, but let's double check our charges. Sodium's a +1, chlorine is a -1. So this is going to be NaCl. And silver nitrate, silver is Ag. If you look on the periodic table, it has a charge of +1. Nitrate ends in ATE. This is a polyatomic. If I pull out my list, nitrate is NO3 with a -1 charge. So NO3 with a -1 charge. Well, this +1 cancels that -1. So I don't have to crisscross charges in this example. Now, let's look at our states of matter for those two. It says solutions, plural. Plural solutions of sodium chloride and silver nitrate. That means that both of these substances are solutions, which means that they are aqueous. Aqueous. They will produce, so I'm going to draw my arrow, aqueous sodium nitrate. Okay, sodium is Na+1. Nitrate, we've already figured out, is NO3 with a -1. Again, +1, -1. I don't have to crisscross charges. And it says that's aqueous, so I'm going to put AQ. And I'm going to put my little plus sign. Silver chloride precipitate. Silver is Ag with a +1 charge. Chloride is Cl with a -1 charge. Again, +1, -1. I don't have to crisscross charges. Precipitate, we saw earlier, means that it's a solid substance. So this is AgCl solid. Now, if I go through and try to balance this, 1 sodium, 1 sodium, 1 chlorine, 1 chlorine, 1 silver, 1 silver, 1 nitrate, 1 nitrate, it's already balanced. So that is how I write this equation. Last example, solid phosphorus combines with oxygen. Solid diphosphorus pentoxide is formed. We've got a bunch of them with prefixes again. So these are molecular substances, nonmetals and nonmetals. So let's start off with our top. Solid phosphorus. Phosphorus is just P. And it's a solid, so I'm going to put an S after it. Combines with, that's my plus sign, oxygen, which is O2. Now, again, oxygen in nature occurs as a gas. When those two combine, solid diphosphorus pentoxide is formed. So those two things are combining. I'm going to draw my yield arrow. Diphosphorus pentoxide. So if I look at my prefixes again, di means 2. So I have 2 phosphorus. And I write that by putting a subscript 2 after my P, which stands for phosphorus. And then pentoxide, well, again, we don't have a pentaoxide because our A dropped out. We just have pentoxide. It is still referring to this 5. So I'm going to have oxygen, and I'm going to have 5 oxygens. So I write this as one compound, P2O5. And it says that that was a solid. Now all I have left to do is balance. I have 5 oxygens and 2 oxygens. Well, 5 and 2 can both go into 10. So I'm going to multiply this by 2. That gives me 2 times 5 is 10. Which means I'm going to multiply this one by 5. That gives me 5 times 2, 10 oxygens. Perfect. 2 times 2 is 4 phosphorus, which means that over here I'm going to put 4 phosphorus. And that's it. We've got our equation, we've got our states of matter for everything, and we've balanced. I hope that was helpful. Again, a huge part of this is naming. Please check out my other videos on naming. Also, a big part of this is balancing. So if you're still having problems balancing, please check out those videos as well. It's easiest It becomes easier as you practice and practice and practice. So go out, find some other examples, find some other